Hello again, Math 109 students. We're on 2.3. 2.3 is the only section we will cover in Chapter 2. It is about circles. What is a circle? A circle is the set of all points that are equidistant from a center point, from a fixed center point. So, let me see if I can draw something like that. So if this is the fixed center point, then if we go the same distance away from that fixed center point in all directions, it would form something like that, something like a circle. May not be a perfect circle that I've drawn there, but maybe you can get the idea from it. All right. So this center point, okay, that center, I'm going to give it the coordinates h, k. All right. And then all of the points on this circle, I'm going to call all those points x, y, x and y. And remember, the definition is that all the points on that circle are a fixed distance. A fixed distance. They are all equidistant. That means they're the same distance away. And that distance away, I'm going to call r for the radius. Okay, so this distance right here, I'm going to call r. Now, can we come up with an equation for all those x, y points? We can. We can come up with an equation because we know a formula for that. We know the distance formula. We would say, or we could use it, the distance formula is kind of like Pythagorean Theorem. So if we think about this as the Pythagorean Theorem, right, there's the right triangle, the right angle. R is the hypotenuse. So this leg right here, Pythagorean Theorem is a squared plus b squared equals c squared. Right? Well, if we call this A, this B, then we could say that A right there is the difference between x and h. So it is x minus h. And then we're going to say x minus h squared because it's a squared. And then b right here is the difference between y and k. So that's y minus k. And since it's b squared, it's squared, equals the hypotenuse, which is r. So equals r squared. That is the equation for a circle. And it is called the standard form of the equation of a circle. All right, that equation down in your notes. So now we can look at this question here and we can answer it. So this is our first example. All right. Write the standard form of the equation of the circle with radius 5 and center -3, 6. All we have to do is plug those numbers in. The 5 goes in for the r, the -3 goes in for the h, the 6 goes in for the k. The x coordinate of the center is the h, the y coordinate of the center is the k. So it's going to be x minus -3 squared plus y minus 6 squared equals 5 squared. Now let me clean that up some. Instead of minus -3, it would be better to write x plus 3 squared plus y minus 6 squared equals 5 squared is just 25. So here is the equation of that circle that it asked me to find the equation of, and it's in standard form. Just point out a couple things. Whatever the sign is of this number, let me get rid of that thing. The sign of this x coordinate, it's always going to be the opposite of that sign in the equation, right? That's a -3, but notice in the equation it's x plus 3. Same thing with the y coordinate. Notice that's a positive 6, but in the equation it's y minus 6, and that's because of this formula. The formula is x minus h and y minus k. Okay? So it's always going to change the sign of that coordinate in the equation. All right, and the radius will always become squared in the equation. All right, next, we're supposed to graph this equation. All right, to graph a circle, you need two things. You need the center, you need the radius. Well, the center is really easy to find. What is the center? Again, now, remember, if positive 3 is in the equation, the actual coordinate of the center is going to be the opposite of that. So it's going to be negative 3. And since negative 2 is in this equation, positive 2 is going to be the y-coordinate of that center. What is the radius? Well, the radius is not 16, but the square root of 16, right? In the equation is r squared, not r. So if this is r squared, then what is r? R is the square root of that. R is 4. And when we have the center and the radius, we can graph it. All right, negative 3, 2 is the center. And then I'm going to go 4 away from that on all sides. So I'm going to go up 4, 2, 3, 4. I'm going to go left 4, 1, 2, 3, 4. I'm going to go down 4, 1, 2, 3, 4. I'm going to go right 4, 1, 2, 3, 4. So I'm there, I'm there, I'm there, and I'm there. And now just draw the circle kind of the best you can. Ooh, that's really bad. It doesn't have to be perfect, but just kind of, that's really hard for me to draw. That's not a bad angle right on this computer screen, but something like that. Okay, and if you don't quite get it there, that's okay. If you don't quite hit it just right, that's okay. We're just kind of getting an idea about the graph of this circle. So how do we do that? We knew this. We found the center and the radius explicitly from the equation, and then we're able to draw the circle from there. All right. Now, this is the same, notice this is the same equation that I just had earlier from the previous example, but now it's asking me to find the intercepts of this graph, meaning the x and y intercepts. So I'm trying to find what that is. Let me get a different color. I'm trying to find what this is and what this is for the x-intercepts. I'm also trying to find what that is and what that is for the y-intercepts. And you can do it by hand, or you can do it in your calculator. I'd have to show you some things about how to do it in your calculator, but I'll show you by hand first. If you want to find any x-intercept for any equation, you plug in 0 for y. Right, anywhere on the x-axis, we have some x-coordinate, but the y-coordinate is always 0. Right? We have some x-coordinate, but the y-coordinate is always 0. And to find the y-intercept, what do you think we do? We plug in 0 for x for the same, for a similar reason, because anytime we're on the y-axis, 0 is always the x-coordinate, and we have some y-coordinate. Okay? So, if I plug in 0 for y, that gives me x plus 3 squared plus 0 minus 2 squared equals 16. And now it's just a matter of doing the algebra to get x by itself. So that gives me x plus 3 squared plus, what is 0 minus 2? It's negative 2. What's negative 2 squared? It's 4. Then subtract 4. I'm doing the square root method. X plus 3 squared equals 12. Then I take the square root of both sides. So x plus 3 equals plus or minus. I'm going to go ahead and break that down. That's going to be 2 root 3. Then I subtract 3 from both sides, and I've got my x-intercepts. X is equal to negative 3 plus or minus 2 root 3. So I have 2 x-intercepts, and they're both at this weird number, this weird irrational decimal number. We could find the the decimal approximations of those just by typing it in our calculator, -3 plus 2 square root 3, and we can get the decimals. But I think this is good enough for now. We can leave it as this answer. This is an exact answer. Okay, let's do something similar to find the y-intercept. We're going to say, we're going to plug in 0 for x. 0 plus 3 squared plus y minus 2 squared equals 16. So what's that going to be? That's going to be 3. 0 plus 2 is 3. 3 squared is 9 plus y minus 2 squared equals 16. Subtract the 9. Y minus 2 squared equals 16 minus 9 is 7. Square root both sides. Y minus 2 equals plus or minus square root 7. Now I add 2, and I've got my y-intercepts. My y-intercepts are 2 plus or minus the square root of 7. So I've got 2 y-intercepts as well as 2 x-intercepts. Just as we saw up here, when we looked at the graph, we saw that it crosses the x-axis twice and the y-axis twice. If I wanted to write these as an ordered pair, it would be -3 plus 2 root 3, comma 0. That would be one x-intercept. -3 minus 2 root 3, comma 0 would be my other x-intercept. So if I had to write it as ordered pairs, these would be the ordered pairs that would correspond to that. And if I had to write the y-intercept as ordered pairs, it would be 0, comma 2 plus root 7 and 0, comma 2 minus root 7. And again, those are the ordered pairs that would correspond to that answer. All right, the next problem is a problem about a different form of the equation of a circle, not standard form, but something called general form. All right, let me take an aside here and talk about general form. All right, general form for the equation of a circle is this. It is x squared plus y squared plus ax plus by plus c equals 0. All right, this is general form, not standard form, but general form. Okay, you can see that the next problem we have is it wants me to graph this equation, and this equation is in general form, not standard form. The big advantage to standard form is the radius and the center are so easy to see. They're explicitly given to you in standard form, whereas in general form, they are not. I can't tell what the radius and what the center coordinates are just by looking at that general form equation. So we're going to have to learn how to go from the general equation to standard form, or also the opposite way, go from standard to general. How do we go from this general form equation to standard form? All right, here's how we're going to do it. We're going to put the two x terms beside each other, so x squared plus 4x, and leave a little space. Put the two y terms beside each other, y squared minus 6y, and leave a little space. Equals, and then take the constant, which in this case is the 12, and move it to the other side, so that's -12. All right, now standard form is like x minus h squared, so we want this to be a perfect square trinomial, and we talked about this a little bit in a previous video when we were talking about completing the square method for solving quadratic equations. Well, we're going to do something like that here. We're going to complete the square. Complete the square. Let me remind you how to do it. What you do to complete the square, we want to know, what do I add here to make this into a perfect square trinomial for these x's? What you do is you take the middle term, which is the 4, you divide it by 2 and square it. Divide it by 2 and square it. So 4 divided by 2 is what? It's 2. Then square it. What's that? It's 4. So to complete the square there, I'm going to say plus 4. And I can do that as long as I do it to the other side also. What about with the y? Same thing. Take that negative 6, divide it by 2, and square it. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I'm going to add 9 here. And again, I've got to add 9 to the other side. So now, how does x squared plus 4x plus 4 factor? X plus 2 and x plus 2, or I'm going to write x plus 2 squared. How does y squared minus 6y plus 9 factor? Y minus 3, y minus 3. So I'm going to write y minus 3 squared equals negative 12 plus 4 plus 9, that says. Negative 12, that's going to be 1. So here is my standard form. Standard form. So now I can find easily my center and my radius. The center is negative 2, 3. The radius is the square root of 1, which is still just 1. And now I can graph it. Negative 2, 3. Alright, negative 2, 3 is my center. I didn't do that too good, did I? Let me try that again. Negative 2, 3 is my center. And from there, I'm going to go 1 away on all sides. So I'm going to go 1 this way, 1 this way, 1 this way, and 1 this way. And draw my circle. Alright, and that's how we do that. Alright, this is the last example. It's a pretty involved example. Alright, this time it wants us to find the general equation. That's the x squared plus y squared plus ax plus by plus c equals 0. Whose center is 1, negative 2. So it gives us the center. It gives us the center. And whose graph contains the point 4, negative 2. Well, if I know the center and the radius, then I can get standard form. I do know the center, but I don't know the radius, but it gives me the center and a point on the circle so that I can find the radius. If I find the distance between the center and the radius, if I find the distance between the center and the point on the circle, then I know the radius. Right? I'm going to find the distance. I'm going to say 1 minus 4 squared plus negative 2 minus negative 2 squared. So I'm just finding the distance between these 2 points. And that's going to be the square root of negative 3 squared plus 0 squared. And that's the square root of 9, which is 3. So the radius is 3. So now I can say the standard form of the circle, standard form, is x minus 1 squared plus y plus 2 squared equals 9. All right, there's my center. Okay, that's where I got the 1 and the 2 and negative 2 from. And there's my radius. That's where I got the 9 from. So now, how do I go from standard form to general form? All you have to, it's not going to be too bad. All you have to do to go to general form is just go ahead and distribute everything, expand these things, combine your like terms, and arrange it the way it's supposed to be. So let's go through that. So x minus 1 squared, that's x minus 1 times x minus 1. That's going to be x squared minus 2x plus 1 when you FOIL it out and combine your like terms. Well, this is y plus 2 times y plus 2, and that's going to be plus y squared plus 4y plus 4. All right, and I'm going to go ahead and move my 9 over here, right? So it's going to be minus 9 equals 0. So now I can combine all my like terms. So x squared, and remember it's x squared plus y squared plus ax plus by plus c equals 0. So my x squared term comes first. My y squared term comes next. Then my x terms, that's minus 2x. Then my y terms, that's plus 4y. Then my constant term, so that's going to be 1 plus 4 minus 9. That's going to be 5 minus 9. That's minus 4 equals 0. This is the general equation of the circle, and I think I'm done. I think that's what it asked. Yeah, that's what it asked me to do. So that's the answer. And that's it for 2.3. Good luck on the 2.3 assignment. I will see you again. And when I do, it will be in chapter 3, beginning 3.1.